Hello and welcome everyone. We're right at the end of trigonometry. We have two separate lessons for chapter review. So I'm breaking it up into two parts, mainly because trigonometry was a fairly big topic, pretty fun, but there was lots to it. This first topic review is going to be focused predominantly on the questions where we have to find a side length. So this will include, yes, some Pythag, but all of that SOHCAHTOA stuff that we just learnt this year, and also some angles of elevation and depression as well. All right, so let's just get straight into it. So the way it's going to work is I'll have some examples, which I'll run through with you guys, just covering, one of each type really. And then there's a couple questions for you guys to practice at the end. And you would have seen when you clicked on the lesson, the link for more practice questions for you guys to do. Okay, so example number one, here it is. We're finding a side length. We want to find the value of x to one decimal place. By the way, if you do ever end up with any questions that don't ask you what to round to, in that sort of circumstance, you have the freedom to round your answer to whatever you want. In this case, we don't have such luxuries. We have to round to one decimal place. But it actually turns out okay for this one, I'm pretty sure, when we have a look at it. Okay, so first example. So we're trying to find a length. So I would typically start with just writing SOHCAHTOA down because, hey, I'm still trying to learn what sine, cos, and tan all mean. So by having that there, it helps us with the second step at least anyway. First step, we need to label the two sides that we're interested in here. One side is blank. We do not care about that side. As the other two sides that are involved, there's the side we're trying to find, which is the opposite side. And then there's the side length which we've been given, that's the hypotenuse. This triangle is an O and H triangle, which, looking up at SOHCAHTOA, O and H belongs to sine. So this will be a sine question. So step one is done. Step two, we need to write out the sine ratio. So sine of the angle, remember, angle always goes with the trig. So sine 30 will be equal to, check it out, it's O and then H, right? O and then H, the order is important. So O needs to come first. O was the value x, H was the hypotenuse, which was 23. We've done our second step, which is the trickiest step of trigonometry. It is writing out the trig ratio using SOHCAHTOA. Now that we've done that, really simple for side lengths. All we do to finish off the question is we either times or divide. Remember, when x is on the top means we times. And you probably remember what to do if x happened to be on the bottom. All right, so since x is on the top, this will be a times question. So for us to get the value x, it'll be 23, always putting the side length first, times sine 30, putting the trig thing last. Typing that in the calculator, pressing equals, you get 11.5. The units were centimeters. It's already to one decimal place. And the first example's done. All right, hopefully that made sense. If you haven't yet, I should have mentioned at the start, you will need your book, pen, and calculator for this lesson. The calculator you will need for the couple questions you guys are going to do at the end. And we are going to get these copied into your book. So if you haven't yet, please pause the video, copy down this first example. For the heading for this lesson, simply topic review 1 would be perfect. Copying the first example. Once that's in, unpause the video and we can move on to the next example. Example 2, we've got another one. This time we've been asked to round it to two decimal places. You're finding the side length. You do the same thing every time. Step 1, we need to label the two sides we have. Check it out. Here is our blank side. We do not care about that side. We've got to label the other two sides. This is the hypotenuse. Right, check it out. It was opposite the 90-degree angle. Right, it's the longest side. That's the hypotenuse. This other side, the 4.43 meters, Is that opposite or adjacent to our included angle? Right, this is the included angle, and it's clearly opposite. This is an O and H. Yet again, we have another sine question. So, on to the crucial step, part 2. We've labeled the sides O and H. We know it's sine. We need to write out the sine ratio. So, sine always include the angle. It's 41 degrees, 15 minutes. So this angle's a little bit over 41 degrees. If you're not sure what that minutes means, you will need to go back to the lesson. We did cover that in detail, what the minutes refer to, but ultimately this angle is in between 41 and 42 degrees, right? It's a little bit above 41 degrees. But for us, we don't do anything different. We do everything the same. We're writing out the trig ratio. Sine 41 degrees in 15 minutes will be equal to opposite and then hypotenuse. Opposite is 4.43. The hypotenuse is x. In this case, you'll note that the x is now on the bottom. Bottom means we need to divide. So this is a sine question where we actually had to divide instead of times. And again, reason for that, x was on the bottom, right? Bottom means divide. So we type this into the calculator, we press equals. If you've forgotten how to type in this into the calculator, what you would do is you would type sine, you would type 41, and then press the degrees, minutes, seconds button, type 15, and then type the degrees, minutes, seconds button again. And you would type in that into the calculator, pressing equals, you end up getting an answer, I think, what is it, 2 decimal places, 6.72 meters. And this second example is done. Make sure you've got this copied into your book. Once it is, you can continue the video and move on to example 3. All right, now we're having a look at it. Okay, it's an angle of depression question. Now remember, these ones here, it's trigonometry, so we're typically dealing with triangles. This particular question has no triangle there, so our first job is going to be to draw up a triangle. Yeah, what is it?
Daddy, I brushed my hair and brushed my teeth, and I even got dressed.
Very good, Liz. Just give me a couple minutes and I'll be with you, okay? All right, so let's have a look. So let's get our triangle drawn up. So we've got a person standing on top of a 30-meter high building. Here is building. It is 30 meters high. Here he is. And he is shining a laser with an angle of depression of 50 degrees. Now remember, if you've got your laser with you, whether it's a laser pointer or some sort of futuristic laser gun, if you're pointing directly ahead, there it is. This is you aiming your laser horizontally. If you're shining that laser with an angle of depression of 50 degrees, right, here it is. What that means is from the horizontal, from you facing it straight ahead, you've dropped it down 50 degrees and you're actually shining the laser down in this direction. That was 50 degrees there. And obviously this was the ground. Okay, what's happened here is we've created a right-angled triangle. Okay, so we've got 30 meters, we've got 50 degrees. We're going to use that alternate angle trick again. Again, I personally would have used complementary angles. Those two top angles at the top need to add up to 90. So I would have had that's a 40 degrees there. But most people prefer to use their alternate angles, which is, just as, it's probably more fun, I guess. If that's 50 degrees, this angle up here, if you follow the Z shape, alternate angles, that tells us that this angle down here is also going to be 50 degrees. Alternate angles are equal. Who would have thought year 7 was useful? So in orange here, this is our triangle. Now that we have the triangle, now the question just becomes a normal trigonometry question. I might actually just redraw the triangle just away from everything else, just to make it a little bit less confusing. So this is the triangle. That's a 90 degree. We had 50 degrees here. That was 30 meters. And what are we trying to find? How far from the base of the building does the laser hit? So the laser came down and hit the ground here. They're asking us to find this distance. I'm going to call that x. So this is our triangle, and now you just do the question just like normal. Let's label the sides. We have opposite, we have adjacent. That's cool. O and A, which one is it? O and A belongs to tan. This is going to be a tan question. So tan, 50 degrees. Tan is equal to opposite and then adjacent. 30 over x. X is on the bottom. Bottom means divide. Always put the side length first, so it's 30 divided by tan, 50. You then type that in your calculator. You press the equals button. You get your answer. We weren't told what to round to, so I'm just going to round it to one decimal place. 25.2 meters. That's how far away the laser hit the ground from the base of the building. So these questions do have the added challenge of, they don't give you the triangle. You need to read the words, create your own diagram, and from that diagram, you will end up with a triangle. So that was an example of angle of depression, finding a side length. All right, final example for today. Example 4, we're just been straight up just asked to find the perimeter of this triangle. So no tricks, we've been given an angle, we've been given one side length. We need to find the perimeter. Remember, the perimeter is the distance around the outside. So ultimately, we just need to find, the length of these two missing sides, add all three sides together, and we're done. All right, let's start off by finding the length of this side, x. So, just using normal trigonometry, we have opposite, we have adjacent. Okay, this is going to be another 10 question. So to find this first side, x, we have tan 40 is equal to opposite over adjacent. X is on top this time. So it's going to be, when it's on top, we times 18.2 times tan 40. We type in the calculator, we press equals. We haven't been told what to round to. So I'll round to one decimal place. That'll be accurate enough for us. Okay, 15.3 centimeters. I guess the length in the actual question was given to one decimal place. So we'll just sort of take the lead on that. If you wanted to round to like 2 or 3 decimal places, that's fine. Your answer will actually have more accuracy than mine. But one decimal place will be fine for me. All right, so we have our first length. So I'm going to get rid of this x here. We actually know the length of this side. It is 15.3 centimeters. Now for us to find the perimeter, we just need the length of this final side here. Again, you could use trig again, but we now already know the length of these two sides. It actually is going to be quicker if we use Pythag. Remember Pythagoras' theorem, we learnt it in year 8. It's occasionally useful for trigonometry. And in this case, yes, we can find our missing side length. I'm referring to this one here, just by using Pythag. So that length will just be the square root of our first side squared plus our second side squared. If you've completely forgotten your Pythag, don't sweat it. You need to go back to lesson 1 of trigonometry. We actually did a review on Pythagoras' theorem there. And you end up getting 23.8 centimeters. There it is. We have all 3 sides. Therefore, what's our perimeter going to be? The perimeter, capital P, is going to be equal to, and you just need to, of course, add the 3 sides together. And press equals. And you found the perimeter. Okay, so there's our 4 examples taking us through, a little bit of, like, I know it's not completely comprehensive of every single type of question, but hopefully that should remind you and refresh your memory of all the main different types of side length questions you could be asked. I'm going to give you guys a couple, make sure you do have the examples written down in your book. There's just 2 questions for you to do today, right? The video is already quite long. Here's 2 questions. I want you to pause the video, have a quick go, try the best you can at finding the side length of both of these. Once you have the answers, unpause the video. I'll give you the solutions and we can move on with the rest of our day. Okay, so for the first one here, you should have ended up having cos and you should have times. You should have ended up with 10.9 meters. And this one here, you had opposite and hypotenuse. This was a sine, and you would have needed to have divided it. And 22.7 meters was the length of that one there. Right, hopefully this has helped. Hopefully you're feeling fairly confident with finding the side lengths. If you do have any questions, you guys know what to do. Leave a comment either here or on Canvas. I'll see it either way, and I'll see you for the next one. Okay, bye.